So here's the last piece of number 1 from the 2014 AB and BC exam. They said that this function here, a of t, is going to model the number of pounds of grass clippings that are in a bin as the grass clippings decompose over a certain time frame. They say that that function only holds from 0 to 30. Now what they say in part D, it says for t values greater than 30, so there's still grass left in the bin at the 30th day, so it still needs to decompose a little bit further. The linear approximation, which they define to be L of t, and a linear approximation is simply the equation of a tangent line at a certain point. In this case, the tangent line is going to be based at the t value of 30. They say that this is a better model for the amount of grass clippings remaining in the bin. So the exponential function models the amount of grass in the bin from 0 to 30, and then from 30 onward, the tangent line that picks up on the graph at 30, comma a of 30, is going to be used for the remainder of the decomposition process. It wants us to use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show the work that leads to your answer. So we need to find the equation of this tangent line first. We need to find L of t. So the equation of the tangent line is going to have a slope in it that's going to come from evaluating the derivative of a at 30. And so back in part A, we looked at a way to estimate the value of a derivative using the calculator at a certain point. And if you went ahead and used that feature here from the calculator, I think I can go back to my home screen here and actually recall it. Yeah, if I just go second enter a couple times. We did this back in part A. So I typed in the function I wanted to know the derivative of. I typed in the variable that I had tossed into the calculator. I don't want the derivative at 15, which I did, and I guess it was part B we wanted the derivative at 15. In this case, I want to know the value of the derivative at 30. If you evaluate this, you end up with the slope of your tangent line. So that's going to be negative 0.055976212 And I'm just being better safe than sorry. I'm taking all the accuracy that the calculator provides me with there for that answer, only because I don't want to round off something now and then lose a silly point later on for rounding off in the middle and then rounding off again later at the end. So there's the slope of our tangent line. What's the point of tangency? So the point of tangency has to have a t value of 30. And the y value is going to be whatever a of 30 is. So if you wanted to figure out what a of 30 is, you can do that with the calculator. I'm going to actually make this reappear. I'm going to kind of take what I think is the quicker way. I already have the function typed in essentially here. I just want to evaluate it not at a general value x, I want to evaluate it at 30. So I'm figuring out what a of 30 is by using the calculator to evaluate this. And so a of 30 is going to be that value. So after 30 days, we have 0.78 pounds of grass left in the bin, still needing to decompose. And again, I'm going to take more digits of accuracy than just the standard 3 here. Same reason as I spoke about a few seconds ago. So what's the equation of our tangent line? Well, the equation of our tangent line, if we wanted to use point slope form, would be y minus y1's this 0.78 value. And I'm not going to type it all in here, or write it all out here. I'll type it all into the calculator when we go there to get our answer. So y minus 0.78 is going to be equal to negative 0.055 times the quantity t, or x, minus x1 or t1, which is 30. So what is the formula for L of t? Well, L of t is going to basically be this equation once it's solved for y. To solve for y, you would just add 0.78 to this other side. So if we had 0.78 and then minus 0.055 times the quantity t minus 30, here's your formula for L of t. Here's the linear approximation to this function at t equals 30. Now we want to use this to predict when there will be a ½ pound of grass clippings remaining in the bin. So we would basically want to put 1/2 right here. Well, if the calculator's in play, what you can do is you can graph this line, and then you can graph y equals 1/2, and you can use the calculator to solve this equation graphically, which is definitely going to be pretty quick. So if we go ahead and type in the equation of our tangent line, and I am going to type in all the digits of accuracy that I had on that 0.78 value from earlier. Which is a pain, but it's better to be safe than sorry. Same thing with the slope. I'm not just going to put negative 0.055. I'm going for everything that I copied down a minute or two ago. And then times the quantity x or t minus 30. So that will be the line that goes through the point 30 comma 0.78. And I also want to figure out when that line's y value is 0.5. So if I graph these two things, I can kind of see it way off at the edge of the screen here, but if I think about it, my window from a previous part only extends to 30. This linear approximation holds for values bigger than 30. So I'm just going to extend that a little bit further along. I'll knock it up to 45. I think I saw a lot of empty space at the bottom of the graph, so I'm just going to change this to -1. And I'm going to change this to maybe +5, just so that we don't see quite as much extra space. We want to figure out what this t value is, where the linear approximation, which models the amount of grass clippings left in the bin from 30 onward, we want to figure out when that equals this fixed y value of 1/2. And so if you use the calculate feature on the intersect feature from the calculate menu on the calculator to determine that, you end up with your answer. Happens to be at day 35. To be accurate to 3 digits, it'd be 35.054 days.